Hi, electronics engineers. Today we are going to see about the next topic about transistor. It is an invention of this electronic device is one of the invention of an electronics. It is a base components of an for every electronics application also. First of all, we see what is a transistor. The transistor name is derived from transfer resistor. We're going to transfer resistance from input to output side. Initially transfer the low resistance path to high resistance path. One of the main application of a transistor, it acts as a switch. It is mainly used in a digital circuit. It acts as a switching by blocking and allowing the signal zeros and ones. And another main application of a transistor, it is an amplifier. Mainly used in sound application systems. We already know about what is an amplifier. Once the weak signal, you have to write booster into right. Once that weak signal you have to go into boost, then you have to reach the input signal into output signal. This is an amplification. The main, we call it is lot of transistors derived we call based on the operation. We call this a bipolar transistor, unipolar transistor, and next we call a field effect transistor and metal oxide semiconductor, field effect transistor. These are all variety types of transistors available in nowadays. The most of main application for a transistor, that is we depend on application we control and amplification process. We last class we see about the semiconductor. Already said any electronic devices is a base is in a semiconductor, that is a p type and n type semiconductor. That's the same here. It is a construction also based on that is like we consider as a sandwich, that is NPN or PNP. Okay, right? There is two type of semiconductor is in between another type of semiconductor. For example, right, NPN, there is a sandwich is a p type semiconductor. For PNP semiconductor, the n type is should be the sandwich. The like a structure should be like a sandwich structure. The reason we go for why the sandwich, because we already see the PN junction. The first application is a switching application, and here it is going to amplify the based on input signal. The input current, we are going to amplify the input signal according to the required output signal. So based on this, we classified it into two type of transistor, that is NPN transistor and PNP transistor. We go for the terminals. Already we have every electronic devices, they have a terminals. For PN junction diode, it has a two terminal. Likewise, the transistor has a three terminals. We call it as a base, emitter, and collector. Just like a consider, it's a base is it act as a gate. The emitter, it should be the name itself, we can emit the current, and the collector itself to going to collect the current. So it has a three terminals. One is it is a base, emitter, and collector. This we call it also a region, that is emitter region, base region, and collector region. This region surface or dimensions is depend upon doping. Already we know about what is doping. The doping is adding of impurities. Why we are adding of impurities means you have to going to increase the current conduction. How much amount of I have to increase the current conduction, that is all depend upon adding of impurities. So likewise, here it is for example in a base region, the limited amount of doping should be added. In a emitter region, that is a moderate amount of doping is added. In a collector region, it should be a high doping level should be answered. So in the region size, the collector should be a larger, the emitter should be a moderate, and base should be a which should be a thin. This is one of the variety. And then in a symbol, have a three terminals. There is a in a symbol there have a there is a closed structure, because in a semiconductor it is it's nothing about the sand. So a single layer of a sand should be created three layers inbuilt. There is a three layers, base, and then emitter, and then collector. So in a emitter side there is an arrow mark. That arrow mark we call it is that mention the direction of the current. At the same time, the three terminals, and it acts as a right, three layers and three regions. That likewise we call it as two junction, right? We call it as a emitter based junction and a collector based junction. This two junction is mainly right based on the operation of the biasing. Already we say, right, what is a biasing? Every component should be activate, or every component should be performs based on the characteristics or based on the what type of biasing applied. Likewise here we call it as, right, there are two junction. One is emitter base and a collector base junction, mainly for the application. Already we say there are two application. One is a switch. In the switch they have a two control, one is on, another one is off, and another third that is a second application, it acts as amplifier. Okay, it has a three operating region, that is for a transistor. It has a three operating regions. So one is a cutoff region, another one is an active region, another one is a saturation region. Suppose your transistor has been used as an application of a switch, means for on condition means you have to use a saturation region for the both the junction, that is emitter based junction and a collector based junction should be in a forward bias. Suppose our transistor should be act as in a switch in off condition, should be in the region of operating region of cutoff region, that is the both the junction emitter base and a collector base junction are in a reverse bias junction, that is reverse bias. Suppose our transistor can be act as an amplifier, so one junction has been right forward bias and the another junction should be right as in a reverse bias. So this kind of right operating region our transistor should be act. Then so physical structure of a transistor, right? So we mention a number, the basic transistor, that is a BC547. We initially B, it is made up of, right, the material is made up of a silicon, and a C, it is for an application of low frequency, and the version number is 547. These transistors, right, mainly majorly focused on based on the application of a configuration. For example, it has three types of configuration. The first type is a common base configuration, and second type is a common emitter configuration, and third we act as a common collector configuration. I already said this is mainly focused on the application, switching and amplifier. Based on the configuration, our transistor should be act as a switch and amplifier, and another one more application, impedance matching, because in electrical circuit you have to be right to match the impedance of a 50 ohm resistance. For example, common base right configuration, we have to use the application of a video amplifier. For a common emitter, it should be act as an audio amplifier. For example, common collector, it should be act as an source impedance matching application. See, before that we go see what is a current gain, because here it is a transistor is a current control device, BJT transistor current control device. Here we going to write control the current based on the right based on how much amount of voltage should be applied, that is based on the biasing, forward biasing or reverse biasing. This is one important point you have to note, that the BJT, that is a transistor, is a current control device, and then it act also based on a majority of charge carriers and minority of charge carriers, both the things. So that's why we call it as a bipolar junction transistor. First of all, right, what is a current gain? You already know what is about the gain. Gain is nothing about the ratio of output to and the input. Here it is a current, means the output current divided by input current. We call it as a current gain. Here we call the term is called current amplification factor. For example, we go for common base, means their current amplification factor is alpha. For a common emitter configuration, means the current amplification factor is a beta. For common collector configuration, means the current amplification factor is gamma. Based on this alpha and beta, right, the alpha value should be always that is less than 1, and beta value is always be greater than 1. So that should be a numerical value to find out a current gain for common base and common emitter. Then before going to write the common configuration, the common base, we have to just consider the base has been common to the input and output terminal. For example, common base means the base should be a common, the input should be a emitter terminal, and the output should be a collector terminal. The same thing has been a common emitter configuration. The emitter is act as a common to the input and output. Here it is the input should be a base terminal and output should be a collector terminal. And the same as the third type configuration, common collector configuration. The collectors act as a common, and the base should be act as an input terminal, and emitter should be act as a collector terminal. Based on this configuration, we are going to design an application. Initially we have two characteristics. One characteristics we call it as input characteristics, another characteristics has been output characteristics. Because already we said the transistor should be act as an amplifier. The amplifier is nothing about to boost up the weak signal. Here it is a boost up the weak signal means the input signal should be boost up to the related to the output signal. For example, common base configuration, there is a common base configuration, the input characteristics and output characteristics, right? We already write what kind of application we have to going to use. Suppose we write it has just been considered as an switch means on condition means you have to write emitter based junction and collector based junction should be act as an forward bias. Suppose we should be in a off condition means the cutoff region both the junctions should be reverse bias. Here it is we consider only amplifier. So amplifier means or both the junction, one junction emitter based junction should be a forward bias and collector based junction should be a reverse bias. So likewise you have to connect the input side that related to the corresponding to the output side. For example, common base configuration, the input current should be IE current, that is emitter current. The input voltage is emitter base voltage. You have to write this is an input current and input current and input voltage. Likewise, the same for an output current should be in a IC, that is a collector current, and an output voltage should be VCB. Based on these parameters, you have to find out the H parameters. H parameter is a mathematical analysis for a small signal parameters, small signal frequency or small signal voltage. H parameter, it has 4 parameters. One is input impedance, and second is a reverse voltage gain, and third is a forward current gain, and last parameters is output admittance. The input impedance is nothing about is R is equal to V by I. The reverse voltage gain is that is input voltage by output voltage, because the reverse voltage gain, and forward current gain means that is output current divided by input current. The admittance should be that is the inverse of a resistance. We find out that is output voltage by output current. We have to using these parameters we find out the H parameters. So likewise we have to find the input characteristics, that is the same act as an output characteristics also. For example, you have the parameter is based on the depletion region. Once the emitter based junction should be narrow emitter, narrow depletion region means it should be a forward bias. The emitter based junction should be a wide depletion region means it should be act as an reverse bias. Based on this operation, we has been considered as an application of switch and off, and at the same time also amplifier. For example, the common base configuration, the input current is that is emitter current, the output current is a collector current. Both are always similarity property. So it acts as an VDA amplifier, because the VDA we not going to boost up any signal. Whatever the input signal is presented, that signal should be present in the outside also. So the common base mainly the IB, that is emitter current, directly proportional to the output current IC. For example, that is common emitter configuration, that is base current, because the base current, the reason is already in initial stage we say the base region, it is a lightly doped. We already saw the doping, that is doping means the adding of improving the current conduction. Already the base region is very thin, so likewise there is a very small amount of current only flow in the base region. At the same time, in a common emitter, the output current is IC, that is a collector current. Already the collector region should be heavily doped, so it has a collector current, that is a more amount of current flow in the collector region. So initially in this way we clearly say the IB is very small and IC should be very high. So the input current should be more than output current. So it acts as an audio amplifier, that is a sound amplifier. For example, the next we go for an common collector. It has also called as a source follower. In a source follower, we mainly source follower in the field effect transistor. We called as a emitter follower. It is mainly used in a low signal amplifier and low signal impedance matching. You have to match the 50 ohm resistance between the input circuit and output circuit in a small signal analysis. Then we have to find out the H parameters of an right, every common base and common emitter and common collector. Generally, we have to find out based on constant voltage and constant current. For example, if we're going to find out for an input admittance and reverse voltage gain, means you have to write the output voltage should be constant. At the same time, we have to find out the forward current gain and output impedance, means the input voltage should be constant. Likewise, we have to mention default value, set the value, then we have to find out the parameters. We call it as H, that is I means that is a input admittance, and HA, that is HA or HO, this is called output admittance, and HF should be the forward current gain, and HR, and that is based on base means B, or emitter means E, and then collector means C. These are all maybe in a small letters, because while using a small signal analysis or low frequency applications or low voltage signal, we mention or we indicate only small letters. For high power analysis or high loss signals, mainly used for capital letters. In a maximum, we see in electrical parameters or electrical terms, we use capital letters. In electronics parts, mainly we use the small letters because of a reason of small power analysis. This is an inverted of an transistor. Based on these transistors, right, we go for the same field effect transistors. The field effect transistors mainly used for the same. It is comes under the junction transistor. It is based for voltage control devices, right? Initially, we see BJT is a current control device. Next, we see the field control transistor should be an voltage, that is voltage control device. Right. These transistors mainly focus on low power application and amplification analysis. We additionally add in a field effect transistor like a semiconductor part, N type and P type semiconductor. We had some that is metal and oxide, that is called metal oxide semiconductor field effect transistor. We call it as a MOSFET. These MOSFETs are mainly next type of invention in electronics. This MOSFET classified in two types. One is a depletion MOSFET. It is almost the same. It acts as a FET, JFET, that is a junction. And another MOSFET is called enhancement MOSFET. This enhancement MOSFET mainly used for storage application. The charge, that is we call it a channel modulation. How much amount of channel should be changed in between the two layers of an between the N type and P type. At the same time, it also acts as a PN junction depletion agent. So the third MOSFET nowadays mainly focusing on the MOSFET, that is a metal oxide semiconductor. It is a starting era for an VLSI. That's divided into NMOS and PMOS. That is a combination of CMOS, that is a complement metal oxide semiconductor. The electronic device is a subject. This is next part of things mainly focused on the wearable devices and very large scale integration, very large scale small integration. This kind of subjects we requiring very important for an electronic device subject. The electronic subject and the main components is act as a MOSFET component. So from the last summary of the last two session, what is we see the last this two session. First we see what is electronics, what is EC, what is how the terms has been derived from EC, and what is difference. A lot of the students has been confusion between what is electronics, what is electrical. We give some idea behind the based on application. You have to do any specific task that we call this an electronics. There is an any just should be a control on and off, that should be, we call it as an electrical part. Then you can easily understand means the high voltage, the high end device or high volt devices are electrical, and low voltage applications are from electronics, and AC supply and DC supply. And next we see what is the important about what are the electronic components of any electronic circuit or any electronic application. We require both passive components and active components. The combination of active components and passive components only we see electronic circuit. And then a very important power supply circuit, there is various stages and various block of a power supply circuit. First we see the transformer and the step down transformer, then the rectifier section, then the filter section, and then we see the IC voltage regulator section. Then we go for semiconductor. What is a semiconductor? It is a act between the conductor and insulator. Based on the room temperature, based on the what kind of voltage we apply. And then we have two types of material, silicon and germanium. Maximum use silicon, that is a negative temperature coefficient, that is NTC. So that is one of the principle behind that silicons only maximum using a semi silicon for all the electronic device. It acts as a semiconductor. Then we go start with a small device, that is a base, that is an base subject of an electronic device, that is a PN junction. All the electronic devices, almost the operation is based on that is a forward bias and reverse bias. That is the junction, the depletion region, one stage it should be disappear, that is the current should be flow in a forward bias. At one stage the depletion region should be wide, that should be in a reverse bias. Based on this, and both that is a charge carriers, based on the minority charge carriers, majority charge carriers, based on this, then we call it as two types of that is a breakdown also. One is a Zener breakdown, another one is avalanche breakdown. Suppose we have to write our device should be act as a voltage regulator, means the reverse, because the PN junction diode will conduct only less amount in a reverse bias, should be a microampere. For that conduction increase in a reverse bias condition, we increase in a Zener diode, we increase small amount of doping. So in that the reverse also there is a current conduction produced due to the doping configuration, plus that is a minority of volts. That should be happen at one stage, that should be you have to amount of increasing doping, amount of voltage applying, that should be happening. The reverse voltage concept, the reverse voltage concept which comes under that is a breakdown voltage. At one stage our junction should be breakdown. That breakdown is called, it is a Zener breakdown and avalanche breakdown. It should be lesser than 6 volt, we call it a Zener breakdown. It should be greater than 6 volt, that should be avalanche breakdown. Based on the principle of avalanche, that is a multiplication of charge carriers. In a Zener, it is the reverse voltage amount of reverse voltage should be increased. These are all the parameters should be used. The second application you generally use for an voltage regulator or voltage stabilizer, we use a Zener diode. Then we see the transistors, the main, once again the main applications, and how the transistors be classified, how the transistors should be constructed, and how much amount they region. Then based on the region, based on the doping, we deciding the current conduction factor. Then based on the junction of the bias, we decide the what type of application we required. Then finally, without a transistor, there is no electronic devices in the world. Then most of in digital world, in a digital world, all the digital components inside there is a transistor, a lot of transistors. That law is a Moore's law. Based on the Moore's law, nowadays a lot of transistors are day to day building more. Based on the technology VLSI, the size should be minimizing, should be in a nanometer size. These are all the history of an evolution of an electronic device. The next emerging technology we going all are in the smart and wearable devices. Nowadays all the wearable devices are that is all electronic devices that should be placed in olden days should be placed in a PCB board. Nowadays all should be minimized to SMT, that is a surface mounted technology. Then we go for thin film based on the micro and based on the nanometer size. Day to day life our electronic devices are developing step by step. But one thing, the old theory concepts and old that diagrams still should be not changed. That basic fundamental concepts as every electronics engineer should be known. At this point I stop my lecture. We see you on next class. Thank you. Mudi Lemon, sir.